Welcome to the Math 159 Gould Chapter 3 Section 2 video. We're going to be talking about what's an unusual observation. Okay, so we talked last time about how the mean is a measure of center. The mean tells you what's typical or usual. And we talked about the standard deviation. Let's write this down. So the mean, what is a typical value? Typical or usual value. And then we talked about the standard deviation, which tells us typically how far from the mean are usual values. So now we're going to talk about the flip side of this. What's unusual? Okay, so the first thing that we're going to talk about is something called the empirical rule. So the empirical rule is a rule of thumb. So a rule of thumb means it's not like completely accurate, but it's generally accurate. So the empirical rule tells us about what to expect from symmetric distributions. So this only applies to symmetric distributions. And we've talked about that a while ago. The shape of the graph, it has to have that bell curve, right? The mode, the high point has to be in the middle, and the left and right tail need to be roughly the same length. So what does the empirical rule tell you? So first, the empirical rule tells you that about 68% of the observations are within one standard deviation of the mean. And I'll explain what this means in a second. I'll draw a picture. Part 2 of the empirical rule says about 95% of the observations are within 2 standard deviations of the mean. And again, I'll explain what this means in a minute. 3, what is the third thing the empirical rule says? About 99% of the observations are within 3 standard deviations of the mean. Okay, so what does this mean? Let's draw a picture. And we're going to illustrate it with an example. So let's come up with some data. So here is an actual journal article on the National Library of Medicine, which is part of the National Institutes of Health, which looks at the length or durations of human pregnancies. This is published in 2006 in the Singapore Medical Journal. So they looked at how long human pregnancies are, and what they found, conclusion, the mean gestational age at the onset of labor for women native to the area of study was 277 days. You should recognize that word mean. That's the mean, the typical value. So what they're saying is that typically women in Singapore or wherever this was done had a 272 day long pregnancy. And what was the standard deviation? 9 days. So I'm going to copy this. Okay, so let's paste it and let's talk about, well, what does it mean when we say this? Okay, so assuming that the length of pregnancy is a symmetric distribution, and if you were to look at the data, you would find that it is. The typical value in the middle for a pregnancy is 277 days. Now, because pregnancies are symmetrically distributed, 68% of women will be within 1 standard deviation of the mean. The mean here is 277 days. So, what does it mean to be within 1 standard deviation? It means you start at the mean, and then you can add the standard deviation. The standard deviation is 9. So 277 plus 9 is 286. Now you can also subtract 9. 277 minus 9 is... one second, I need to do this in my head. Is 268. Oops, can't write. So, any pregnancy that is between 268 and 286 days long is within one standard deviation. Okay, so you get to start at the mean, you add one standard deviation, and you subtract one standard deviation. Between those two numbers is said to be within one standard deviation. So what do we know? About 68% of women, or 68% of pregnancies, are between 268 and 286 days long. Okay, that's the one standard deviation of the mean. Well, then we go two standard deviations of the mean. Two standard deviations of the mean means you would add 9 once and then add 9 twice. So you add another 9. 286 plus 9 is 295. And if you subtract 9 again, you get 259. So anything between 259 and 295 is within 2 standard deviations. So what do we know? About 95% of pregnancies are between 259 and 295 days long. Okay, that's the 95% are within 2 standard deviations of the mean, right? Because you can add 9 twice, or you can subtract 9 twice. Finally, we can go one more time. You can add 9 one more time, and you get 304. You subtract 9 one more time, and you get 200. I can't subtract. 250. So, 95% of pregnancies are between 250 and 304 days long. So I want to point out something. 99% is basically all right? There's only like 1% left. So usually we summarize this rule as saying basically almost all pregnancies will be within 3 standard deviations of the mean. In other words, between 250 and 304 days long. A highly unusual pregnancy would be more than 304 days or less than 250 days. And if you were to go look up online how many days, how long a pregnancy is for a premature baby, it's like something less than 250 because those are unusual. Okay, so this empirical rule gives you a rough guide of like, oh, well, how far from the mean will a certain percentage of the population probably be? Well, 68% will be within 1 standard deviation, 95 within 2, and 99% within 3 standard deviations. Okay, now we're going to talk about a way to quantify how unusual an observation is. So this is something called z-scores. Okay, so what do z-scores do? Z-scores quantify how far from the mean an observation is. In other words, how unusual an observation is. Okay, so the z-scores are mostly useful when you're making comparisons between different things, between different groups. So let me give you an example. Let's say I'm teaching 2 different courses, a night course and a morning course. So there's a night course and a morning course. And let's say for the morning course, the average, remember x with a bar over it is the average, or the mean, was 70. And the standard deviation was 5. And for the night course, let's say that the mean was 90 and the standard deviation was 1. Okay, so you can see the people in the night course on average, had much higher scores. The average was 90. In the morning course, they had on average, or a typical score, average score, whatever word you want to use, was much lower at a 70. But let's say you wanted to make a comparison between people from the different classes. So let's say a student in the night course scored a 94. Whereas a student, or actually no, let's say a student in the night course scored an 86. There we go. Whereas a student in the morning course scored a 75. Which student did better when compared to their peers in their section, let's call it. So there's a night section and a morning section. There we go. So what are we doing here? The person at night scored an 86. The person in the morning scored a 75. We're not just going to compare their scores. 86 is obviously higher than 75. What we're wondering is, hey, this person did an 86. Let's compare them to people in their course. And this person got a 75. Let's compare them to people in their course. If you want to look at their place in the course, how well they did, who did better? So a z-score is useful for this. So let me first explain how to calculate a z-score. So a z-score is the observation or value minus the mean for that group divided by the standard deviation. In symbols, the way we would usually write this is x minus x bar over s. Okay, so what does the z-score do? The z-scores measure how far from the typical value, from the usual, or the mean, in terms of the standard deviation. So let me plug in some numbers and we'll see what this means. So let's do the z-score for the night person. So we're going to put z night. Oops, let me erase that. So we're going to do the z-score for the person in the night section. So what was the observation for the person in the night section? 86. That was their score. What was the average from that class? 90. And then what was the standard deviation? 1. 86 minus 90 is negative 4. And negative 4 divided by 1 is negative 4. So what does this negative 4 mean? It means this person scored 4 standard deviations less than the mean. So if the mean is what typical, they scored below average. And how much did they score below average? 4 standard deviations. Let's now calculate the z-score for the person in the morning section. So z morning. Well, what was their observation? 70. I'm sorry, 75. What was the average from the morning? 70. And what was the standard deviation? 5. 75 minus 70 is 5. And 5 divided by 5 is 1. So how did this person score? This person scored 1 standard deviation more than the mean. In other words, they scored above average. Okay, so what this is telling us is because the z-score of the person in the morning is 1, they, compared to their peers, they were above average by 1 standard deviation. The person with the higher score of 86 compared to their peers scored below the average compared to their peers. So the score of 75 was above average in their section, whereas the score of 86 was below average in their section. In other words, the 75 was comparatively better than the 86. So this is what confuses people sometimes. Yes, I understand that the score of 75 is lower than a score of 86, but let's just say that the morning test was harder, so everyone just got a lower score. Okay? But that score of 75 was above average compared to the score of 86, which was below average. So we say that the 75 has a higher z-score of 1 compared to -4. So the 75 was comparatively better than the 86. And this is the end of the video. Thank you.